Okay. No, just college in general. I mean, how are you guys? How do you guys view college right now?
Not going.
All right. All right.
Not doing it.
Because I was just telling I was just telling Katrina, what you guys are going through is like infinitely way tougher than like a regular high school. I think you're already aware of that. And let me give you some perspective, okay? If you compared the work that you're doing now to like what you did maybe like in the sixth grade, right? Imagine the sixth grade version of you right now, and they have to talk to what are you in the 10th grade now? Or you guys are in the 10th grade? Okay, imagine if the sixth grade version of you talk to you now. Do you think the sixth grade version of you could take like the work stress that you guys are going through right now? Okay, certain classes, okay. But for the most part, wait, you guys are in high school for the most part then, yeah? Except Indigo. Okay. But
Middle school. Middle school.
weren't you guys kind of scared about high school, right?
No, not at all.
You were.
No. So that's my own fault.
No, I'm just saying that if you were even mildly stressed about high school, a good way to think about it is
I wasn't even
okay,
scared of middle school.
Fayed, guys. Just think about it this way: you're already doing it right now, and you guys are handling it right as if it's just everyday life. When you get to college, your brain's gonna acclimate to that level. It's already ready for that level. And second of all, so you're good, okay? So you got to think of it that way. It's not like you can't handle college. Maybe we're just kind of working up to that level. And number two, your schedule right now and what you're having to deal with, and like trying to find times to retake things and trying to reschedule things, that is priceless. That's gonna prepare you for college. Like I think college is in a lot of ways less brutal than what you guys have to go through. You guys only see like I was talking to Katrina. You guys only see me like once a week, right? Some classes in college you get to see the teachers, or you have to see the teachers 3 times a week. That's way more support. But the average college student in college is going to be like, I can't do this. Like I only see my teacher 3 times a week. Whereas for most of you guys, it's like this is a blessing. I get to see him 2 more times to figure out what the heck is going on in class. You guys are super well versed for college. Trust me. So just know in the back of your head, all this is like mega training. Like if you're choosing to go, you don't have you can choose not to go. Yeah.
So you know like Westfield High School and stuff?
No.
You know Westfield High
No.
School?
No, I'm not familiar. No.
What about Torrey Pines?
I heard about Torrey Pines, about the rigor, but I still think in a lot of ways you having to like plan out your own schedule instead of just going every day.
What do you think is like harder, Torrey Pines or not?
I think Torrey Pines is tough in the sense that there's a lot of pressure mounting from other parents there, right? College is a different type of pressure. Like it's just different. I'm not gonna say it's harder. It's just different. That type of stress is this: you're on your own, and you don't have anyone telling you what to do. You got to plan out your own schedule. Well, guess what? Don't most of you feel like you guys are already doing that right now? That's the exact type of stress you were preparing for right now. Like including myself, when I got to college, I had no training for that. I was like, what about all the updates on the whiteboard? Aren't you gonna tell us what's due? It's like, no, you read the syllabus and you figure out what's due at the end of the month. That's on you. I'm not gonna say anything more. And the teachers are like, you get 1 test a month. Good luck. And most kids are like, we only get like 1 or 2 tests? No way. But most of you guys are like, okay, what's new? You know, you guys have been doing it since like freshman, 8th grade, 7th grade, 6th grade. If you guys started that early, so you guys are more than prepared. Okay, yeah.
What would you say, like, you don't need to tell us exactly, but what would you say that your grades were like, or were you struggling that first month?
Yeah. I had no idea what I was doing. Yeah. I would say like, okay, so my personal experience was the first 3 months in college were not good. Like I was definitely like, I don't know what the readings are. Wait, what was due last week? Oh my God, you know, like, and then I would say about the 4th month is where like I started to get the hang of things, and I had to make up things. I had to go talk to my professors. Doesn't that sound familiar? You guys are already having an email and stuff, right? I had to like, do I have to email? And I was like talking to my friends. I'm like, guys, like, should I email? It's like, dude, just do it. Just email. It's like, I don't know. Like, how are they gonna think about it? It's like, dude, think about it. He's got like 800 kids. He probably doesn't care anyway. So just email. He's not gonna judge you. It's like, all right, 3 weeks later, I finally email. Then I get yelled at the professor. Just like, why did you not email me? Like, you should have just told me. I'm like, well, I don't know. I was nervous. I'm like a freshman, you know? They're like, that's the problem, you freshman, you know? Anyways, you see that now? All this stuff now, like, you having to irk up the courage to email us and say sorry or whatever for whatever reason, right?
I feel like, personally,
Yeah.
it's not necessarily the material in the classes that's extremely difficult for me. It's figuring out
The
ways
time
to
management,
get work
right?
done, getting work in, and like fitting my own schedule because I've never done anything.
That's college.
Yeah.
So what you're going through, and what's hard on it is that you guys are really young. And you guys have to experience it now.
We're gonna start getting gray hairs by what?
Next year. My
Yeah.
mom found like this.
Maybe, yeah. It's fine. Like, what I'm saying is, like, I know it's hard because you guys still have that pressure of, like, from parents and teachers to be like, I have to get a certain GPA and stuff like that. You know, I think it's only getting worse for you guys too. Like, it's just tougher.
Yeah.
But I think here, getting, like, whatever grade you get here as opposed to another school means a lot more. Like, what you get here is seriously what you earn. You really had to go through the mud to get things done, okay? You had to figure out through all this paperwork. It's brutal for us to be like, you know, like, look on your cover sheet, look on my website, figure it out, you know? And for most of you guys, I don't know how you guys adapted. There's no way I could have done this. If I was a kid, I would not choose this school. Like, I know myself too well. I need the everyday support, okay? But you're already kind of getting used to that, and then what you're going through makes you so much strong. I know it sounds cheesy, but it really does make you stronger. If you did not choose to die from, you know, these things that you're having to go through, you have no choice but to get literally tougher skin and, like, a tougher mindset because you've lived through it, okay? So by the time you're in college, it's just gonna, like, what changes is that thing called the subconscious that you don't know is working in its background, that does things on its own, like the way you react to things, you can't help it. That subconscious is getting trained right now by what you're going through. So by the time you get to college, you're not even going to know you're doing things well, but you just are, okay? So just trust yourself, okay? All right, guys. That being said, sorry to, like, talk on and on for some of you guys that are just like, I just want to do the math. This is okay. Let's start with the warm-up, okay? Try your best, okay? Try your best. That's my message. Just try your best. Just do your best, because by the end, you're just going to be stronger, okay? All right. Don't worry. I'm not thinking that all of us are going to get this right at all, but just give it a shot. I'm going to give you 2 problems. Okay? Are any of these a perfect square? Sorry. Oh, can you close the door, my friend? Maybe that should help a little bit. Or a difference of squares. If you can't answer that, then you can also answer this one. What is the quadratic formula? You can use anything you want to come up with this. I'm not expecting you to memorize this, but hey, it'd be kind of cool if some of you guys memorize. All right, everyone, please stand up now. Let's find a space on the whiteboard and let's just do some work, okay? Feel free to copy each other too if you don't know what's going on. This is not a test, obviously, so I think it helps to kind of copy other people that do know what they're doing, so you can kind of learn from what's happening. Erase any space you see on a whiteboard. Grab a whiteboard too. So Hassan, I know you're kind of eyeing one right there, so go ahead and take that if you like. There's that giant whiteboard. You can also move that giant whiteboard if you like. Any whiteboard you like, okay? There's one over there, Fayad. Yep, there's another one next to Fayad. There's tons of space all over there. Right there in that tubby. Right there in that tubby. So is the first one, are any of these a perfect square or a difference of squares? And if you don't know how to do that, just say, what is a quadratic formula? What is the quadratic formula?
Okay.
Wait for the second one. Just
Oh, just x is equal to, like, Or well, the quadratic formula would be x is equal to.
Yeah, for the sec minus.
Oh. Yeah, I mean, you can write it out, but just tell me if it is or isn't. It's pretty much a yes or no question, but you have to show me with some work. If you can. Yeah.
Okay, well, I know for a fact that that one probably isn't a perfect square because A is a perfect square by A times C times 2. So this one is. Yeah, I know which one. 1 times 4 times 4. So B is 16.
I like your facial gestures, Dash. That's funny. You make me crack up.
First one is because like the square root of a squared so 2 times 8, which is 16. So
Okay, good. Very good. Yeah, it is. How did you remember that? That's hard. That's really hard to remember that. That's not easy. All right, I'm gonna give you guys like one more minute, and then figure this one out. This one's pretty tough. Yeah. Oh, you know, it's okay. So it's not technically a. It's the square root of a and the square root of c. Oh, okay. So I don't know what the actual. I have no idea how you did that, but
I recognize that from my AP Bible.
really?
Yeah.
Huh. I actually don't know a formal name for that, but if you remember that, that's
Yeah, I just use that to find populations and heterozygous I guess, and homozygous population.
Oh, you know what you're describing might be higher level statistics. That's actually higher than this type of math. Yeah, it's pretty cool. Yeah, you might actually be using. All right, guys, let's go ahead and have a seat, and then I'm gonna go through some of these answers. Okay. So I think you're having a seat. Okay, I like that. Okay. So here is the quadratic formula. So check to see the quadratic formula. Are you guys aware of what it's supposed to solve for? What the heck? Yeah. What's it solve for then? Yeah.
The two roots well, it doesn't have to be always 2.
We're just familiar with 2 roots. Yeah.
It's like x cubed and it's 3 x.
Oh. Oh, look at you. Okay, look at you. Good, so you know. So yeah, like this basically solves for where your roots are, like where your graph crosses the x-axis. Okay, and then for this here, some people just kind of recognize this by eye somehow. Like I don't know how you're able to do it, but I think some people are just able to see that ends up being x plus 8 squared. So that is what's called a perfect square. Let me show you the formal way to check. Okay, the formal way to check. Okay, yes. How do you know the method of doing this, good sir? Okay, would you care to help me explain this?
Okay, so you have to first see if the first term is a perfect square.
Okay, so the first term being the a component, right, in front of. Okay, so is it a perfect square? Okay, so what would be the root of 1? It'd just be 1. Okay.
Then the last term, is it a perfect square? It is.
8 squared. Okay, so those.
To see if the middle term is 2ab, which it is.
Okay, so technically, you know
Times 1 is 8.
what's stinky is that I forgot to say that it's not technically 2 times a. It's 2 times the square root of a. If you have to know, you know what I mean? Because that's a. Square root of a is 1, right? And then the c is 64, but the square root of c is 8. So you just got to see if this middle term is indeed what this should be. So this would be 2 times 1 times 8. And it is. So this concludes that this is a perfect square. Okay. And if you forgot what that should look like, you take the 2 roots here. And basically that, like a 1x plus 8 squared, that becomes your answer. Okay. You take the 1 and the 8 and you put it together in that one quotient there. Okay. This one I think is a little trickier. This one's not quite as obvious actually. Is this a difference of squares or a perfect square? Did anybody get this one? Okay, Petunia. How did you get that this was a difference of squares? Oh. Okay, and I think once you set this up this way, then let me ask you: can I take the square root of both numbers? Okay. Not yeah. Oh, actually, wait, can I? Oh, I'm sorry, not negative 64, just 64. You're absolutely I'm sorry. Well, hey, you're not supposed to say that. We're not there yet. Okay. So that's 8 squared, and then this is technically 1 is in the front. So that's 1 squared, right? Or x squared, even. I'm sorry. Yeah, it's just x squared. And then you have to say that is this a difference? Yes or no? Is it? Yeah. If you have a difference of squares, then or you have a difference between two numbers that you can take the square root of, you have a difference of squares. The answer will then be just x, instead of x plus 8 squared, it's x plus 8 times x minus 8. Okay? And this was x plus 8 squared. That's the difference. No pun intended. Okay? Are we good?
Another way of solving is you could just find the square root of both of them, and then you have to just write plus minus 8. So x could be plus minus 8. That's another way.
Who's teaching the class? Fayad? No, I'm just kidding. Fayad. No, actually, it's always the students that teach me something new that I didn't see. So I'll show you some stuff that I remember on my first year of teaching here. I was like, oh, you're right. I didn't know that. And the student would always get me good. Okay. All right. So that's a little bit of review. You will need to know how to identify those types. Yes, Eva? I do not. Would you care to? You're like, do you know it? I think Miss Flo sung it one time, and I was like, what's going on? But it's cool. It is actually really cool. Okay, we were doing 3.1 this whole time without you even knowing, okay? So 3.1 is a lot of review. I mean, we still got a few more things for 3.1, but yeah, that was technically 3.1. But the stuff that you've done, like, I think they put it in 3.1, but the truth is you've already done this stuff, okay? So what you did was nothing new, but yet they put it in the 3.1 as if it was something new. Solving quadratic equations by factoring, which I'm going to have to make clear about some things in this chapter. Because I think there's some regression in this chapter. It's things that you don't need to do. The first, one of the first new concepts. I like taking notes on new things that I like it. Just move around, right? This is a free learning space, so just move around and find a good place for you to say. Even if you want to sit down on the couch, just don't talk over there. Translate sentences into equations. Equations. Translate the sentences into equations. So you're going to write a quadratic, sorry, that's really weird, quadratic equation into standard form.
Did everyone sign it?
Yeah, did you guys all sign the sign-in sheet? Just pass it around so we all do. With 3/4 and positive 5 as its roots. This is your. I'm going to put this. This is the sentence. This is your sentence. Sorry, that's really weird, but that's just a sentence. Okay? Write a quadratic equation into standard form with -3/4 and 5 as its roots. What the heck does that mean? I do not know. I do not know. Any guesses as to how to solve this? I think we're good, Sophia. Just leave it there. Yeah, there you go. Handle it, Sophia. Yeah. All right. This is your sentence, and you're going to translate it now. This is what your translated equation will look like. Your answer will be x plus 3/4 times x minus 5 is equal to 0. That's it. Why is it that this is the answer to our sentence? Yes.
Because when you're finding roots, you find the inverse.
Oh, yeah. So, like, if you set this up here, x plus 3/4 equals 0, right? You subtracted 3/4 from both sides,
It would be x equals negative.
which is the root, right?
Yeah, so you just find the inverse.
Yeah, I like what you're saying. You take like sort of like the sine inverse of what you have, -3/4, and you just change the sign up and you put it in this binomial. That's it. As the first part of the equation. The second piece here is x minus 5 is equal to 0. If you added 5 to both sides, guess what? That was one of your roots. It's just the equation. So, like, if you think about it, the sentence, the only thing different is in the sentence, write a quadratic equation into standard form with these roots. These roots were the answers to your problem. So what you have to do is you have to set it up backwards. As if, like, before you had to set up equal to 0 and you had to subtract the roots from both sides. Does that make sense? So you just have to kind of do it backwards, okay? So I'm going to give you 2 more problems now. I'm going to give you 2 example problems, okay? I'm going to give you this one. So I want you to, A is going to be, you're going to factor out or just find the roots for x squared minus 4x minus 21. And then B will be translate. Oh, I'm sorry. No, not translate. Sorry, let me get the book first. It's a lot more quiet today, huh? There's a lot less people today, huh? Do you guys prefer it with more people or less people? A little more less. Wow, Ruby. Right. Like, in a lot of ways, you are a collegiate student. In the fact that you like, I don't care. I'll just adapt as it is. Okay, example. What's that? You're hearing that's all that matters. Write a quadratic equation in standard form. With the negative 1/3 and 6 as its roots. Okay. Yes, Sophia. Dang it. Yes, of course I can, Sophia. Okay, everybody up? Get on up, kids. Get on up, children. Okay. Wait a minute. Find a new space on the whiteboard. Yes. New. Huh? You really like your spaces? Okay, fine. Just keep them there. All right, cool. I just wanted some people to have a new opportunity. That's all. A new opportunity is all I give. That's all I offer. That's all I want. You guys want to turn the lights too? You want to turn the lights? Alright. No. You could factor out or you could factor out or just find the roots. If you want, you could just use the quadratic formula. If you don't want to factor it out, just use the quadratic formula. Oh, here? To the left? Oh. Into the light? Like here? Does that help? Could just be my writing too, so. Wait a minute, why is Mr. Wee writing a part C down? I did not. I had nothing today.
You don't drink coffee?
I do not, actually. Yeah.
What?
No, it's weird, right? Huh?
I kind of want to see what you're like.
Oh, really?
Yeah, kind of.
I don't know. I don't know if you guys can handle it. Watch, I'm just like a lot slower. I love it! Dash, very beautiful. Petunia, very concise. Dash, very beautiful. Sorry, both are beautiful. Sorry. Right, go. Let's see where you know now, Fayad. What do you know, Fayad? Fayad, you're not supposed to know about I.
Yes, I do.
How do you know about I? How do you know about I? You're not supposed to know. Not you. Not you, Fayad. You guys ready for part D? No, I'm just kidding. I'm just kidding. I'm going to freeze. Freeze! What? True. But I'm gonna look for something else though, Luciana. Loophole. Technically it's an error, Mr. Wee. It don't work.
Technically, we're not wrong.
Technically you're not.
Say we're wrong.
But I can. Okay, yeah, that's true, yeah. Okay, 4AC or 2A. Post Malone. Post Malone. Yeah, for some reason no one understands my ones, so yes, that is the one. That is the one. You are absolutely correct. Oh, was it Dash? Was it easy? Okay, yeah, you're probably right. It's easy. Yes? You don't know? What is it? That's technically right, but there's a little bit more to it. But yes, you're technically right, Luciana. I love that your urge to do the math leaves you unsatisfied. There are some things your calculator cannot do that your brain can do. It depends on the setting, the person making the settings here. Okay, 2 times e, 2e, 2r, 2r. 4 plus or minus the square root of 16. something wrong here? Whoops, that's 21, you silly dope. Huh? Yes, you may. Go ahead. You're gonna miss out. Go ahead. Yeah. Hey, it's true. Good point. Fine. I like. It did. Yes, it did. Okay. You guys ready to check your answers? Because I just barely finished mine. Okay. All right. I did not want to factor it out. I'm lazy. In a different way, I'm lazy that I don't want to remember. I'm just lazy. I don't want to learn. I don't want to do the diamond problem and stuff. I'm just not good at factoring. So, in a weird way, I'm lazy for using the quadratic formula, which I think does take more work, but you're never wrong if you use the quadratic formula correctly. So, x equals 7, and I got -3. Is that what you guys got? Yeah, very good. This is what B should look like. And then A is supposed to look like, it doesn't have to look like this. You can solve it however you want, but I wanted to solve it with the quadratic formula. So on 3.1, I think it says, let me show you something that says 3.1. You guys good with this so far? Yeah. You just have to do, okay, go ahead and write that down really quick, Luciana. No, because I'm gonna put something over this. So at least write down this first part up here. Okay, over 2 times 1. Okay. Okay, so here on 3.1, there's example 4. It says to factor trinomials. You do not have to do this anymore. Okay, because you know the quadratic formula, you never have to do stuff like this again. Okay, so again, I'm gonna say it one more time. If it says to factor trinomials, if it says to factor trinomials and you have any homework in here that says this is from, like over here, like check for understanding, if it says examples 2 through 4, if any of these look like example 3, or what was it? Yeah, that was example 4. Example 4. You do not have to factor it out anymore. I just want you to solve it, okay? And I think the quadratic formula is the easiest way to do it now, because as long as you do it right, you're never wrong. It's not a really nice thing to say in life, though, is it? As long as you don't do it wrong, you're not going to be wrong, right? No, it's okay. You can make mistakes. That's fine. Okay, C is going to answer all the questions, right? Except for one question. Square root of 16 is +4 or -4, you could say. The square root of 1 is 1. Did anybody get 3 root 2 for the... Oh, you did? Okay, smarty pants. How about -18? Stop it. You stop. Okay. It's an error right now. All I should compute as is error in my head does not compute because we're going to learn about things called imaginary numbers. Some of you guys might know about this, some of you not. Okay, complex numbers. Okay, new notes. 3-2. This leads me into some new stuff. The first thing you're going to learn is square roots of negative numbers. We learned that it's just not really possible to get a square root of a negative number. with the numbers that we currently know. Square roots of negative numbers. What do you think is a common mistake? Like a common answer if someone asks, what is the square root of negative 16? What do you think the common mistake and answer would be, Katrina? It would be. And then I would ask you, then take negative 4 and square it. And then you would say what? It's actually equal to positive 16. So it doesn't work out. So what could it be? So let's do some review really quick. The square root of 9, the way you would handle this technically would be you can factor this out into two roots or two factors of 9. And if they are a pair, you pull it out and you just get a clean number of 3. Okay? That's a bullet point. The bullet point is review, and then the next bullet point is the square root of negative 1. We're going to learn everything with the square root of negative 1. It doesn't exist in real numbers. So up to this point, all you understand are real numbers. This is where we enter a weird, funky dimension. Okay? The dimensions. So, with, just write this down. I'm not going to say anything else. With imaginary numbers. Root. So I said, but with imaginary numbers, there is an imaginary root for negative 1. Think of it this way. Just think of it logically. The square root of negative 1 is not a real number. But if we had to make up a root number for negative 1, it won't be a real number. It just can't be. We've tried all the real numbers we know, and it still doesn't work. So literally, the square root of negative 1 would have to be two imaginary numbers that we don't know. We signify imaginary numbers with what letter? What letter do we use to signify imaginary numbers? Indigo. I. So we literally have two I's that represent two imaginary numbers. And since they're a pair, they can come out. The only way that we're going to have a square root to a negative 1 is if it was an imaginary number. Does that make sense? Again, let me reiterate. The square root of negative 1 is I. The square root of negative 1 is I. The square root of negative 1 is I. Yes?
But you can make I to another too. If you do I squared, it will become negative.
Oh, look at you! So we go backwards. If you take I squared, which technically is the same thing as saying the square root of negative 1 squared, what would you get, Fayed? I squared is equal to negative 1. Let me reiterate that one more time. Two things you must know. I is equal to the square root of negative 1, but if you square I, you get negative 1. Oh, is that a brain teaser or what? Huh? Okay, let's do some fun, cool things with this new concept of I. Okay? Now, let's go back to that previous problem. How the heck do you solve negative 18? I don't know. Okay? With an I. Wait, yes. Not yet? Okay. Well, let's back up a second. All right? Let's just do 18. What are factors of 18? Just think about that first. Yes.
3 times 3 times 2, which is 3.
Hey, step by step. My brain can't work with that much stuff going on. Stop it. How about just two factors so my brain can comprehend what you're doing? Okay, let's do 9 times 2. Thank you. That makes it a lot easier for me to understand. Okay, and then you break up the 9 into more stuff, which is, why didn't you just tell me that the first time? I'm just kidding. Fine. Okay, that's a pair, but we got a negative 18. We have a negative now. So what other number can we also factor out? If it's not just 18, but now it's negative 18. What do you have to multiply 9 and 2 by to get negative 18? Yeah. So that's how I would do it. I would first just think about the factors and just the positive version of the number you're dealing with, and at the very end, tack on that little -1. Okay, just tack it on there, right? And then, can you dissect a root out of -1? What two factors make -1 if you had to multiply them together? Anybody have any ideas? Yes. I and I, as if it was a comedy movie. I and I. Okay. Aye. So it's not the final answer is not 3 root 2. It's 3I root 2. Was that so bad? Was that a bad one? Was that a bad one? No. Try one at your desk. Try -125. Give it a go, kids. Try your best. Try it. Give it a try. You never know unless you try. Give it a try. What? Every day it's an inspirational speech. Okay. That's how you get yourself out of bed. I have to inspire myself, right? Do I need coffee? One does not need coffee to get through the day. Then I get up. Oh, do you? It's not healthy, young lady.
I'm doing homework sometimes at 12, and all I see of her is listening to music at 12. And I'm
Really?
like, Tessa, what are you doing? What is wrong?
She's texting you. So that means I could email you guys late then too. You guys are up.
I won't respond.
Ah, right. I'll email you guys. Hey guys, I got a new assignment. I didn't see it.
It's due tomorrow. We have a pop quiz tomorrow.
Pop quiz, kids. I was just kidding. Sorry. Yeah. Yeah. It's in your house.
Pop quiz on Friday. Come to Friday at 8 a.m.
All right. Is everybody finished or no?
It's so weird to think that most of the people I know are in school tomorrow and Mondays 8 a.m. to 3 p.m.
And you try to like and then you're like, okay.
Yeah.
Yeah.
All right. What did you guys get? Oh dear, you were very good. Yes. Yes, you did. Really? Hey, go ahead and write it on there. Yeah. Math riddles. Oh, sorry. -I and -I. Sorry. Oh no, just I. Just I. Sorry. Okay, so there we are. I factored out into 25 and 5 first. Then I factored out the 25 into 2 5s, so I took out a 5. But then, since it's negative, I just tacked on the -1 at the very end, so that's 2 i's. I can get them out, so it's 5i root 5. Any questions? All right. I think we're good for now. We're going to move on to another conceptual problem. So bear with me. I think, what is it? It's 10:06. I'm going to get through 2 more bullet point things that we're going to have to do. I'm going to give you 2 sample problems for you to do, okay? That way you get a lot of time on the board just to relax and just to do some problems. Relax. Just not now. Don't you dare. No, I'm just kidding. Yeah. You will soon, okay? So the number 2 is an equation with imaginary numbers. Ooh. Imaginary solutions, actually. Ooh. Okay. So you're going to solve 4x squared plus 100 is equal to 0. You have to solve. Huh? This is 3.2. Sorry. So a few notes back, I maybe I didn't make that clear. I'm sorry. A few notes back, I said we're on 3.2. Here, at where we started to do this, these notes, Sophia, is where it was 3.2. So you can go back in your notes and relabel that as 3.2 somewhere. Okay, where I start to say Review the square root of 9 is equal to 3 and 3. So look for that in your notes. Look for that in your notes. Okay, sorry. Sometimes Mr. Week gets a little gas. Okay. So you have two ways to do this. We have one way. You don't have to remember the name, but technically one way is the square root property. I would just solve it this way. The other way is through factoring, which I don't think many of you guys are a fan of. I wasn't a huge fan when I was younger. So here's this way, 4x squared plus 100. If I want to solve for x, and this isn't like 4x squared plus something x plus a constant, 100, it's just 4x plus 100. Just subtract 100 from both sides, since this isn't like a quadratic formula or anything. I think technically you can solve this with a quadratic formula, okay? So there could be a number 3 here on another way to how to solve this. 4x squared is equal to negative 100. You divide both sides by 4. Uh-oh. Children. How are you going to solve this now? X squared is equal to 20. Negative 25. You might have to. Yes, Tessa?
So you find the square root of each side, so the square root of 5 times 5 times negative 1, which equals 5i.
Look at you. So we had to square root both sides to get x by itself. And then you'd factor out 5 and 5 and negative 1. And if you're real inquisitive about what we just learned about today, those negative 1 can be factored out into 2 i's, which makes this x is equal to 5i. Okay? I'm going to write the other way on how you can do this too. What's going on, good sir? Oh, technically it is a plus or minus 5i. It is. It is technically plus or minus. Yes, you can, but you'd still have to eliminate the risk. Like, there's going to be a 2x. Yes, you do, but you have. It just adds that added complexity of having 2x is equal to 50, I think.
No, it's at 2x is equal to
10i, yes. And you have to divide by 2, so it's the same thing. So another way you can do it is you can factor out the 4, and you'll still end up getting the same answer, because you have to set up x squared plus 25 is equal to 0. I'm just saying that you have multiple ways of getting to the same answer. You have to square root both sides. Again, x is equal to square root of negative 25, which is 5 times 5 times negative 1, which can also be factored into I and I. So your answer is still the same, plus or minus 5i. For a lot of you guys writing this, I think by the time you're finished writing, it's like, wait, didn't I just kind of do most of this stuff here? Okay. And if you really want to make this work, anything that has an x squared, you can actually plug in 4x squared plus 100. That's your A and that's your C. Your B is just not technically there, but it still works. You just plug in 0 for B. This could work theoretically with the quadratic formula as well. So you have 3 ways to figure this out, okay? However you want, okay? You're always going to get to the same answer as long as you're persistent. Okay? One other thing I'm going to teach you in this section before we move on to 3-3 is dividing complex numbers. Oh, I know you guys are going to have fun with this one. This is going to be great. And the example is you're going to have to simplify. Just simplify. Simplify. I can't even talk right. Negative 2i over 3 plus 5i. Now, what was the rule about denominators and fractions? What can you not have in your fraction? What does not look good to a classical mathematician? Like an old one. Yes, Fayad. Stop it. Does anybody remember what you can't have in your what things can you not have in your Tessa? Well, I think you might be able to have a variable, but there's one specific thing I've taught you so far. Yes, Fayad.
a square root.
You can't have a square root, and guess what else you can't have? You can't have an imaginary number. I'm sorry. Yeah, it's adding just I, just a singular I. That's so weird. So weird. Okay, you simplify this by multiplying by what's called a conjugate. You just multiply the bottom by exactly the same thing, only you change it by one sign, and you do it for the top and the bottom. Watch the magic as it unfolds. Sorry, so hold on. If you don't like the way your notes are, sorry. This is the question. This is the question. And then when I rewrite this, I will rewrite the answer. If you don't mind that your answer continues on like that, then you can keep it the way you had it just now. But sometimes I like to say that this is the question, and I like to see the answer on its own. Okay? So I'm going to multiply this as 3 minus 5i times 3 minus 5i. And then, yes, so you can FOIL it or just do the distributed property, whatever makes more sense to you guys. Negative 2i times 3 minus 5i. It's gonna get real nasty real quick. So I'm gonna deal with the bottom first. 3 times 3 and 3 times minus 5i. So what that's gonna look like is, I think that's gonna be 3 times 3 is 9. 3 times minus 5i is minus 15i. And then over here is 5i times 3, which is plus 15i. 5i times negative 5i. That's a little tricky. You multiply the 5s together, which is 5 times 5. So it's minus 25, but then the i's are being multiplied too. That gives me 25i squared. Ooh, what is that going to look like? Let's do the top. Negative 2i times 3 is going to be negative 6i. Negative 2i times negative 10i. I'm getting really tired of saying that. Negative 2i times negative 5i is positive 10i squared. Now, let's do some magic. Do we remember what I squared is equal to? Katrina? Oh, look at you. Yes, you do. You do remember. You do remember. It's 10 times negative 1 over 9. And then the minus 15i and plus 15i kind of cancel out. They're like terms, but they have different signs. And then 25i squared. Like I said, I don't want any i's on the bottom, but do we remember what I squared is equal to? Yes, my pretties. Okay, my precious students. Okay, my precious, my very beautiful, precious students. Okay. Okay, so I have negative 6i minus 10 over 9 plus 25, which gives me negative 6i minus 10 all over 34, and we're done. Okay, let's do some problems. All right. Shh. Fine. You know what? Fine, Fayed. No, because I totally forgot it. Yeah. Wait, who said it? Okay, yes, you're right, Petunia. Yes. You can simplify it further. So, actually, you know what? If the problem says simplify, we go simple. Okay, as simple as it is. Oh, you can factor out 2 out of both the top and the bottom. So you can factor out 2 like this. 2 times negative 3i minus 5. And then on the bottom would be 2 times, what is 34 divided by 2? Nice. Sorry, I looked right at you. You just answered on command. Thank you. That was very nice of you. The 2's will cancel out. So your final answer is technically negative 3i minus 5. I'm going to leave it like that, but you can go simpler. Okay. Yeah, you can factor out negative 1 if you wanted, but that wouldn't make any difference. So I think we're done. Okay? We're done. We done, students. We done. Okay. So here are your 2 problems, kids. Whiteboard time. Yes. Give me 1 second for the part B. A is that, and then B is something else. Hello. Hello, children. Okay, x squared plus. Okay. See, who are we missing today? Mr. Hibbert is not here. Ivory is not here?
Yes, she's in Arizona.
Oh, that's right. I think she mentioned that. Is there any other people we're missing? Oh, where is she? Like, I'm gonna walk around. If anybody needs any assistance, let me know.
Do you want to see the whole negative 1 equals 1? I don't want to break my brain tonight.
Not yet.
This is the very last one. I don't know how she did that. It was me. It was my old tutor. He's really smart then. Yeah. He was 19. No. Wait, is this right? Right.
I haven't even checked. Let me see. Sorry. I'll be honest with you.
Mr. Wee.
I'll be very honest with you.
Solve me. Solve me.
Yeah, I tell you.
What is the right answer for the A?
I don't know yet.
He doesn't
I
know.
don't know yet.
Wait, we're kind of this one.
What'd you get?
I got 3 plus plus 1.
Okay.
Is this right?
3i plus 1?
Got this one.
3i plus 1?
And then it's right.
65 by 2.
Wait, yeah.
8. So 2x.
Very good.
Hold on. Let's redo this. Wait, no. Right to x1 so 8i. What's the answer for the first one? So nobody can figure out how to prove this wrong. Everyone's trying in like the calculus. Let me see that. I don't understand any of this math. So negative 1 equals I times I. Right? And
It's 8.
I forgot how it goes. I'm just gonna go. Why do you still have it? Because we're because Prisoner's Dilemma is like my favorite ever. Prisoner's Dilemma. Because it's a love story. Or her and Optima. I started bringing him colored pens. Because he only had black and it would spice things up. So I have no. He taught me how to take apart science. Yeah, where did you find this person? He was an intern at my dad's job. He does tutoring. But now he doesn't tutor anymore because he gets paid more.
That would be.
And I'm sad because I was really right to I never, we just stopped one day. I never got to be like, oh, bye or whatever. I just left. I just stopped. I don't either.
Just kidding. You're going.
Okay, goosebumps.
Don't tip me. Okay, you're good. Okay. Maybe need more time.
No, I know.
You should have gotten. Okay. I'll say this. A, you should have gotten 1 plus 3i over 2. That's what you should have gotten for A. And then B, I'm going to give you a little bit more time.
Oh, but we already got it.
Shh. Calm. Okay.
What is this calm you speak of?
Coffee. Yeah. Coffee is calming. No, it's not.
I agree with that statement.
You know, the few times I do have coffee, though, I get like really jazzed and crazy.
I want to see that one day.
No, you don't. Yeah. Because you get a bunch of emails and texts from me at this point. Hey guys, what's going on, guys?
How you doing?
Did you guys see this music video?
Like,
Yeah, dude. Like,
what's up?
like,
Which one?
I'll check it out.
You can
Like
be the one
4
where you
a.m.
drink
though,
coffee and be like,
or maybe not now.
what is it?
You know, I'm really behind music because I was listening to like a radio station or like a Spotify, and I was like listening. I was like, oh wow, who is this guy? This new sound. Wow, he's really nice. I was like, guys, you guys have to check out this Post Malone. I was like, yeah. I was like, oh wow, he's the voice of a new generation. He's very hip. No, well, like I didn't know, and I was like, you guys might have never heard of him. And then my friends were like, you're a little behind, dude. Like, check him out on YouTube. I looked up, like 600 million. I guess I'm like the 600 millionth person that like, found him out. Okay, and then the last one should have been x equals 8i. Okay, does anybody have any questions? Hold on. Does anybody have any questions before we move on to 3-3? Okay. Okay, you can do this one at your desk. So before we move on to 3-3, yeah, you can do it on the board. Okay, so 3-3 is the quadratic formula. Uh-oh, that guy again.
Can we call it
That guy again, yeah, sure. And, sorry, that's an ampersand for and. That I didn't draw it very well. That's it. Okay, ampersand, that's an and. The discriminant. Does anybody remember what the discriminant is? So, if I ask you to solve x squared minus 16x is equal to negative 64. The discriminant. Can you guys solve this using the quadratic formula? Okay, go ahead, work at your desk or work on the board if you'd like. Yeah, just go work on the board. Just go on the board. Jeez, guys. If you don't know where to begin, look towards people that you can depend on and be like, okay, they usually get it right, so let's just see what they get, right? Solve this using this quadratic formula. You can. You don't have to, but you may.
Yeah, we just.
Did we? No, we didn't.
Yeah.
In the beginning? Oh, shoot. Yeah, is it? Oh. Or is it... Wait, when did I do that? Did I seriously use the same problem?
Yeah.
That's okay. We'll just.
Yeah, review! 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 Wait, I don't think it's a perfect square. No, but you're good. You keep doing Nice. Hold on, be very careful. This is not a perfect square. This is a deadly problem. This is not a perfect square. Like you
Why
thought.
would you do that?
So
Come on, Mr. Wee. Go tell us. This is a
Maybe it is.
You're 12 years old in 9th grade. I am not this old.
Yes.
I'm in 9th grade.
Alright, it may be a perfect square, but not a perfect square. Okay, go ahead and find it.
I'm average. Just do 4 times. Yeah, I'm turning 13.
So first add 64 to both sides. Okay, so I'm gonna give you that. Oop.
I already did. Wow. How did you figure that out? You are a genius.
Yes.
You added 64. I never would have gotten that.
You know what? Well, I wasn't good at math at that time to understand what to do. It took me a very long time to understand that you had to add 64 to both sides. Not being sarcastic. It really does. Here I am. I'm a math teacher now. Yes. Because you want to set it equal to 0. Which
You always have to set it to 0.
My siblings taught me.
to solve for it, you have x squared. If you have an x squared on this side, oh, not always, yeah. Well, if you want to use a quadratic formula, yes. So that way, do you see your c now? Your a, your b, and your c? Trina?
Why can't I just leave it as negative 64?
Because that's not your c at this point. You will get the wrong answer. No, so like the times that I say you don't have to use the quadratic formula, you don't have to move it to this side, is this. It's like 25, right? If I just wanted to find it there, and it's just 2 numbers, nothing too complicated, I can take the square root and I'm done, right? This has 3 different terms. I'm already really scared. So what I do is I move everything to one side. So it's x squared minus 16x plus 64. I set equal to 0. Then I start figuring out my a, b, and c, and then I start plugging it to the quadratic formula.
Yeah, that's what I realized.
The quadratic formula only works if you set all your a, your b, and your c equal to 0. Okay? It's just, no. But I do have it at 150 a 2. If you want to come to that. Alright,
How do we do this? Can I just write a smiley face and then give an A for effort?
So this is
No, wait, it's on
that's wrong. I feel like it's not. Oh wait.
Alright, guys, let's go ahead and have a seat.
We're already having a seat.
Alright, fine. Alright, Ruby, guys, stop right there. Stop right there. Stop it! Stop! Because that's where I am. I'm exactly at the same point you are. Okay, so, guys, here, I think we're going to have to make a part 2 video that should only be like 5 or 10 minutes, okay? But this is what I was going to get to right now. Let me ask you one more question. If I ask you to solve for this, my next question is, and you have 16 pretty much just by itself over 2, and you get 8. So x should just be equal to 8. Everybody get that? Oh, it's a double. Hold on. You say it's a double root. How many roots do we have? So that was my next question. How many? Oh, you are so good. I like it. Okay, so how many roots do you have? Do we have, or do you, or we have, or you, or we have? And you say how many roots? How many answers? Yeah, yes, Sophia. Oh, fine. Sorry. Okay. Sophia, how many roots do we have, Sophia? How many answers do we have for x? Do we have 2 answers for x? Do we have 1 or do we have none? Well, I had 16 plus or minus the square root of 0, which is 16 plus 0 divided by 2. So that's 16 over 2. I got 8. Does that make sense? Okay, so you had to use a quadratic formula to solve all this. So you only have one root, meaning there's only one answer for x. Sometimes you have x is equal to 7 and -4, if you remember back, or -3. Do you remember that? Where you had a question where you had two answers for x, right? Well, the reason why is you have to look back on this thing. Anything in the quadratic formula, whatever under the square root is what's called the discriminant. It tells you how many roots you will have. If your discriminant is greater than 0, you will have 2 roots. If you have a discriminant, and you saw it, your discriminant was equal to what in this case? If your discriminant is equal to 0, how many roots did you end up having? In this chapter, you will actually have a discriminant that is, guess what? Less than 0. That will give you no real roots. So I'm going to go through a video. Let me give you a little sneak peek at what I'm going to show you. So that's all I wanted you to write for your notes now. You're going to have about 10 more minutes worth of notes, and that's it for this week. But let me show you that last piece of the puzzle I wanted to show you before you leave. Take a look at this guy. I was going to give you this one next. Take a look at this guy. Don't write this down. Just take a look. It's called complex roots, cases where your discriminant is less than 0. I gave you this problem. I would ask you to solve for it, right? You guys would add 13 to both sides, and then you guys define your A, your B, and your C. You guys would go through all this work under the quadratic formula, but look at the very end right here. Look where I'm isolating. Can everybody see that? It's 4 plus or minus the square root of 36. I've already just solved for b squared minus 4ac. What is the discriminant now? Is that greater than 0, equal to 0, or less than 0? That is a value that is way negative. That is less than 0. What you will end up having is an answer with I in it. Does that make sense? But I like that. But let me ask you, is that a real number? Anything with I in it automatically makes it an unreal number. It's imaginary. That's why when I say here, if your discriminant is greater than 0, you have 2 real roots. Sorry, I didn't emphasize that. Those are real roots. If you have equals to 0, you have 1 root, real root. If you have less than 0, you might have imaginary numbers, but they are not real. So by technical definition, you have no real roots. Okay? All right, guys, go ahead and pack up. Put away your desk, or put away your chairs. It might be a tall task to ask you for your desk, okay? And you guys have a wonderful day. I will continue this on part 2 for you. I see you next